what's up, everybody? Welcome to Jupiter Brain. My name is Joshua Torres. Of course, we all know...
Wait, is that recording?
Yeah.
Oh,
yes.
Just making sure. Okay.
Of course, yeah. Great introduction for Albert.
Yes, this is Albert.
And then today we have a very special guest. We have Orion Bruins, you said?
Yes, Bruins.
Bruins, okay.
Like UCLA.
Awesome, yeah. So, Orion... Which, honestly, the first time I met you and you told me your name was Orion, I was like, you have the perfect name for physics.
Yeah, really, right? It's a pretty sweet name.
Yeah. Orion's belt, right? For anybody who's lost over there.
You know, a lot of people say Orion's belt. There is a whole Orion up there, too.
Yeah. Oh, really?
Yeah. He's got like a bow and everything. He's pretty badass.
Oh.
His belt is Orion's belt.
Oh, and of course, then there's a whole Orion, right?
Yes.
Of course. But anyway, so you are a freshman and then a engineering physics major, right?
Yes, sir.
Okay, nice. And how are you enjoying it so far?
I'm a fan. You know, I always like math and stuff. I haven't really taken any physics classes yet, so I'm excited for that. But,
okay.
You know, just sort of making it through right now.
Yeah, gotcha. Yeah, so here at Jupiter Brain, we say that we are engineers by day and philosophers by night. So, of course, we're going to get into some engineering talk, and then hopefully we can do a little bit of philosophizing as well. And yeah, so don't feel like we need to only talk about the physics of music, right? We like to go on tangents upon tangents,
especially down the line. You can go anywhere.
Yes. But anyways, we like to start off every podcast talking about how your week went. So with it being the second to last week, how's your week going?
My week is, you know, it's all right. I should have studied more this week for finals, but you know, I still got the weekend. I still got time. I reserved that right. I don't know. Everything's sort of just cooling down for the semester.
How many hours you taking?
I think I'm at like 14 right now, but a couple of them already ended. Like my bass lesson is over, my jazz combo is over, so it's down to like 12.
Did you have a final in that?
No, because I'm not a music major. I did not have a final. Lucky me.
Oh, what?
Yeah.
Wow.
That's awesome.
Yeah.
Interesting. So, is that like a? So is that a minor or?
No, it's not a minor.
You just take it as a.
Yeah.
Okay, that's awesome.
So, where do you plan to take your engineering physics degree to? Like, do you plan to do PhD?
You know, really, if I'm being completely candid and honest, the goal is to go to like law school after this, because engineering degree looks very attractive on, you know, like a portfolio for that kind of thing. And then, you know, Juris Doctorate. And then I want to be a Supreme Court justice. And then, obviously, the next after that is president, right? Gotta be president.
Yeah.
I like
okay,
that.
Man, you're already blowing my mind over here.
That's
I did
crazy.
not know that that's the path you were wanting to go. That's awesome. Interesting. So can you unpack that a little bit?
Yes.
Like why go this? Why do engineering physics and then
To law school.
So, the first thing that really made me figure that law school would be a good idea afterwards, because initially I was just like, okay, I'll just go PhD in physics. You know, I wasn't even gonna do engineering at first. I was just gonna do flat baseline physics. But my physics teacher in high school told me, like, you know, if you really want to go down a political route, then engineering degrees look great for like high law schools. Like they look at that and they're like, okay, we're gonna accept you for this program. So just sort of planned out that way. But also, you know, interest in law, interest in like economics and like all that kind of stuff, you know, just sort of panned out in a way that seems like the best path.
what is the typical path for like a law student?
Usually like political science or like, you know, there's pre-law programs and all that stuff, but political science is a big one, especially if they're going for politics.
Because I have a friend that took communications and then went to law school.
Oh yeah, that's another good one.
Yeah. That's interesting. I never thought you could go to law school of engineering. That was new to me.
A law school of engineering?
No, I mean you can take engineering to go to law school.
I see. Yeah.
That's cool.
I mean, it
That's
makes
cool.
sense, right? They're just I mean, engineering is essentially just a critical thinking degree, right? And so I'm sure you're going to need to be doing a lot of critical thinking when you go to be a lawyer, right? So that's probably, that makes a whole lot of sense.
Yeah.
And so tell me more about, so you're wanting to be a judge and then the president. So,
Right.
So why that route? Why not just go like be a senator or a mayor?
Yeah, the usual route, right?
Yeah,
People climb up the political ladder.
You know, the thing is, because Supreme Court terms are lifetime, like you can get kicked out if you're, in doing things in bad faith, but it's a lifetime thing. So typically people don't retire from being a Supreme Court justice or move up from being a Supreme Court justice. So it's just like, there's not the law perspective in the office. It's always executive to executive, or like legislative to executive. It's never judicial to executive.
Yeah.
And so, like, I don't want to be extremely political right now. That's not what we're necessarily here for. But like, there is distinctly a fudging of the law going on right now from the executive. Like a lot of, little smears here and there trying to get around laws, almost encouragement of it.
And I know this isn't a political podcast. We try to stay away from politics, but at the same time, like, I'm also very interested and curious. So what do you mean by this smearing? Can you explain a little bit?
I mean, it's just like different funding things, like reallocation of funds, like all the fun stuff, like tariffs and all that stuff. That is legislative action that is meant to be taken. That is not, like, you can choose where to place the funds as the executive, but the actual funding for these programs and whatnot and tariffs and all that stuff, those are meant to be enacted by Congress. And so from the executive right now, we're seeing I don't want to say like a perversion, but like sort of just maybe an overreach of powers. I don't know. I don't want to get too political.
Interesting.
It's controversial.
But I'm just very curious though. Like, honestly, I wouldn't. I don't know. I'm just sort of thrown aback by you wanting to be go to law school and go to be the president. So what? Okay, for one, like, why would you want to be the president? Like, what?
I mean, big boss, big boss.
Okay.
But really, it's just like, why does anybody want to be president? They think that they can make the country a better place. They think that they're the best fit, or at least that's the ideal reason why somebody would want to be president.
Interesting. And so, where does this come from? Are your parents in politics, or
my parents have always like voiced their political opinions. They've never been insecure about it or anything. But like, I want to say this mostly came from me.
Okay. Interesting. Is there like a video you watched, or maybe just like just things in the world that you've been seeing? Like,
I mean, yeah, it's a lot of like, just things that I've seen. Like, people don't like the police.
Yeah.
Like, why don't people like the police? Why do the police have to be a negative thing?
Yeah.
Like, a world without police, everybody would just do whatever they want, right? So it's like, why do people? Yeah, we need them, but people hate them. And it's like immigration. Like, of course, ICE needs to be here, right? Like, ICE needs to function and remove people who are a detriment to our country, but also it should be easier to legally immigrate, right? So there's just a lot of things that you can see in the world, like the judicial system and the prison system have been completely corrupt forever. Like, essentially since America was founded, the judicial and prison systems have been corrupt. Privatized prisons, making money off of prisoners. Like, it's just there's a lot of issues, and not many people want to be the person to solve them, but I would, like, if I have the right people around me, then I believe that I could help this country genuinely.
That's awesome. I love that, man.
Honestly, that's inspiring. I feel like, dang.
Yeah, no, for sure. I mean, one of the reasons why I had really like invited you after like I think maybe I met you the first or second time, and I asked you, we were talking about what you're interested in. You said you were a musician, and you're kind of a quiet guy though, to me anyways, and so I just always, for one, here at Jupiter Brand Physics Society, we believe that the most interesting people are the ones around you, and then at the same time, I always feel like the most quiet ones are they've got something hiding in there that's got to be interesting. And then, like I said, you're a musician, and we've talked about wanting to do an episode on the physics of music.
Right.
So yeah, I'm just super pumped because that's a great way to start a podcast.
That's insane.
But anyway, so how about you tell people sort of what type of musician you are and how you got into that?
Okay, so I am a double bassist. I can play electric bass, but I much prefer the double bass. You know, it's the big one.
Mm-hmm. Yeah.
But
wait, with two different?
No. It's just double bass. I'm
Okay.
not sure why it's called double, but it's really upright bass is definitely a better
Okay.
way to reference it. But I started orchestra way back in 4th grade.
Okay.
And, I wasn't super dedicated to it at that point. I just played music because my dad played music.
Mm-hmm.
So I went through orchestra, all the way through elementary, middle school. And then got to high school and I started playing jazz because the jazz director had invited me to play with them for a contest because their bassist apparently sucked. Like, he didn't show us anything. So I was the fill-in. And,
Nice.
it worked out pretty well. I love jazz now. I was always into it before that. Like, a lot of, whenever you look at it, a lot of music that's, popular and relevant now has jazz fundamentals in it. Because jazz fundamentals are, music fundamentals. There's a lot of jazz theory and, general music theory. Really, jazz theory is, an extension of it. So whenever you look at, Tyler, the Creator, for example, he has a whole lot of jazz theory stuff going on, seventh chords and all that kind of stuff. So it just seems like jazz.
I've heard the same is true for Kendrick Lamar. I believe somebody.
Kendrick.
Because there's I forget who the producer was that he was having a conversation with, but the producer was just like, "Do you realize that a lot of the beats you pick are jazz, have jazz influences?" And he was like, "No," but then after that, it totally changed his selection of beats and things like that.
Yeah. I mean, Kendrick, he has a whole lot of jazz stuff. Really, Pharrell is one of my Pharrell is a jazz man. Even if it's not completely outward, if he's not just saying it out loud, you can hear it in his music.
So, is there a certain, I don't know, tempo or what really is the heartbeat of jazz?
The heartbeat of jazz, it's sort of a hard thing to pin down because jazz itself as a genre started with work songs. Which you might slave music, work songs. It was sort of gospely, but eventually it was it became more mainstream. Slaves were freed, hooray!
Hell yeah!
And then it became more sort of underground kind of music. Prohibition came along. It was the speakeasies. They played jazz. They had bands, and then eventually swing hit, and once you start swinging the notes,
swinging the notes.
Yeah,
Can
a good way to explain
that?
swing is hitting it late.
Okay.
If you're doing an eighth note, just straight eighth note. It's just straight eighth notes. A swing would be it's
okay.
It almost seems like an entirely different rhythmic thing, but it's more of a feel that you give to it. But that's only one part of jazz. There's a whole have you ever heard of bossa nova?
Bossa nova.
Yeah.
It sounds familiar.
It's a Brazilian. It's essentially a branch of Latin jazz. It's Brazilian music. It's super. Yeah, if you want to play some bossa nova, I would gladly listen to some right now.
Let's see. I'm trying to think of which. This is just bossa nova classic. Let's see here. Let's just play one song. Oh, like this?
Yeah.
Okay, yeah, I love this. I don't know if we'll get like a strike for playing this, but yeah, that's something I was thinking about today or the other day, because I was like, yeah, it would be nice to be able to play some music during this to like try to, you know, illustrate with sound like what it is we're trying to say, right? And so I was like, we need to look into like copyright things and stuff like that to figure out exactly like what's okay to play. And then I think I've heard that like as long as you play like a very short bit, like it depends on the timing that you play and something like that, but something for us to worry about later. Anyways.
True. So yeah, there's a whole lot of stuff that goes into jazz, like Latin jazz. What is it? Trad jazz is sort of like the swing that I was talking about. Alternative jazz, freeform jazz. Freeform jazz is real freaky, man.
Okay.
My director told me about this time that he went to a freeform concert, and essentially all they did was just have one guy play a B flat the whole time, and then everybody else took turns soloing over that. So it's definitely an acquired taste. It's very
okay.
So it's very, very improvised.
Yeah, a whole lot of jazz is improv. You know, a good amount is just fully written out, like completed ideas, start to finish. But you know, really, the heart of jazz is improvisation.
Wow, I gotta look this up. Oh my god, the first thing that comes up is SpongeBob for some reason. Freeform jazz SpongeBob. I don't know why, but I've got to play this. I'm sorry, guys.
See what we got.
Yeah.
Freeform jazz?
Taste for freeform jazz.
Interesting. I did not know. Man, SpongeBob's pretty cool.
Yeah. Let's see here. I guess let's maybe click on this one.
Yeah, if you're like, you can hear there's not really a set time to it. I mean, of course there is. Like it's sort of out there, you know, sort of.
But then there's that like that that just is the steady. Is that the B that you're talking about?
No, B.
Okay.
Like whenever I said B, I meant like an actual note, just one continuously droning tone. You know, of course, like freeform jazz is like you can do whatever essentially. Like already jazz is a lot of improv, sort of do whatever. Like sounds good to you, but if you really go too far outside of it, you're gonna get weird looks. With freeform jazz, it's weird by default, so the looks just are weird.
Okay. Yeah. You know, it's this topic is really, I don't know. It's exploded inside of my mind, and it's just like I can't get it out now because it's so fascinating to me. For one, like how much I didn't realize the depth of it, right? And there's so many things about music I have no clue. I'm such a novice, right?
Same for me, man. Same for me.
I played a clarinet when I was in sixth and seventh grade, which we'll get into the physics of a clarinet later. Of
course.
But you know, it's interesting because it seemed like people, let's say like 100 years ago, right? They knew more about like the ingredients of music than we do today. There's like so many different things that you can get into nowadays that, you know, music can just like you can just slip on by music, right? I mean, I love music. I listen to music constantly, and it's the thing that sort of helps like drive me through my day. But there's just like some very like subtle nuances and things that I had no clue about, like for researching for this podcast, like consonance and dissonance. I think I had heard of them, but didn't really understand what they were.
Like at least not in a musical context, you know.
Yeah.
Like we hear resonance before, resonant frequency and all that, and harmonic oscillators and whatnot, but never heard of it in the context of like music. So it's pretty cool.
And until maybe this morning, I couldn't even told you what like a C note is. I was watching this video this morning of this guy playing a piano, and he was like showing you like where all the notes are, right? And one of the things that I found fascinating was that the first pianos, like you couldn't even really play the whole piano. You could only play a certain amount of the piano because a lot of it wasn't tuned to the ear's liking, right? There was a lot of dissonance, or how would you describe dissonance?
Dissonance, it's sort of like a clash, you know, like that's definitely the most elementary way to put it. Is like it's whenever the notes clash.
Yeah.
So essentially, you can think of every note as like a frequency, right? Like every note has a frequency to it, and so with every note there is the undertone and there's the overtone, and so whenever you bring notes together and those tones clash, like you can almost think of it as like a fraction, like here, I got my notes.
Okay, heck yeah. Yeah, because I think there, from what I saw, Pythagoras was the first one to really look at these ratios in
music.
Yeah, in music.
Yeah. So, here it is. So an octave is like A to A, right? Like low A to middle A to high A, right?
Okay.
And so
that's what confused me at first. I was like, wait, there's different A's, but apparently they're like how would you describe their differences?
So every note is either a half step or a whole step apart. Typically, you see it as a whole step. Like if you're just thinking about the flat tones, it's a whole step apart. So A, B, C, D, E, F, G, and then G to A. So it's just those notes, and then they repeat in different octaves. So essentially, there is half tones between those as well. So you can go like A to A sharp, to B sharp, to C, or you could go backwards: C, C flat, B, B flat, A. Right. So it's just each of these divisions, each of these subdivisions is like not divisions, intervals. That's what they're called. Intervals is like A to A sharp is a minor second. So that's one half step. A to B, that's a major second. That's two half steps or one whole step. So whenever you take steps like that, like think about like a tritone. A tritone is three whole steps. So it's A, B, C. A and like if you played A and C at the same time, it would sound very dissonant because the ratio between those frequencies here, I got it written down.
Cool.
The ratio between the frequencies in a tritone is 45/32. That's almost as dissonant as it gets. People called it the Satan's interval, like the devil's interval back in medieval.
Is that like the square root of 2 or something?
Yeah, it's kind of like that.
Yeah, I saw where. Oh my god, it's gonna make me look for this really quick, because it was like the square root of 2 or something like that. I don't know. I imagine it's the same. Where is it? Of course, I'm not gonna be able to find this.
Are you looking for the double tone?
Anyway, it's probably exactly what you said. It's just
it's square root over 2 to the ratio, like square root over 2 to 1, approximately.
Interesting. So I imagine that's the same ratio as what you're talking about. But yeah,
I mean, so dissonance, whenever you really think about it, is just like whenever the fraction gets bigger, like whenever it seems like it's less stable. Because whenever like you play two dissonant tones, like they're like two tones that are dissonant with each other, you get something called beating, which is literally the wavelengths like hitting each other and giving variations in volume.
So is that like Dr. Stapleton actually did his demonstration in one of our differential equations class in harmonic oscillators. He took two tuning forks and he started like ringing them, and it just sounds like a normal sound, right? Because they overlap exactly. But when he tuned the tuning forks to be slightly offset of each other, you can hear the
exactly.
Is that what you're talking about?
Yes.
Interesting.
Okay, that's cool. Wow.
Yeah, interesting.
I love Stapleton's demonstrations. Amazing.
Oh yeah, I got him for calculus too, man. He's great.
Yeah, wait till you get differential equations. He brings. I like it when he brings out the demonstrations. You know, he will bring out like how to show you in visual. That part honestly helps me the most.
Yeah, in math, I feel like you need visuals, right? Like you just, we like to say it all the time. A lot of it just feels like shut up and calculate.
Yeah.
But at the same time, like a lot of professors want us to use our imaginations.
Yes.
They give us like conceptual problems, right?
Yeah.
And so it's like, well, if you guys want us to use our imagination, we need to
See it happen.
Exactly. We need sort of help in seeing like, oh well, how are we supposed to imagine this thing?
In this case, it's how people hear it happen.
Right. Yeah. And so before we get too into this topic, Albert, how was your week?
Oh.
Yeah.
I thought we were okay. So my week has just been. I was sick, and then Thanksgiving we went to Dallas. Because one of my friends never been to Dallas, we brought him to Buc-ee's.
Okay.
His first Buc-ee's experience. It was very funny, very fun. And yeah, I mean, overall, I just think Thanksgiving has been a very fun experience. Went to some friends' host family's house and had some very good food. Yeah. Thanksgiving food's amazing. And then, yeah, just trying to catch up with my finals right now. So I
imagine Malaysia doesn't have a Thanksgiving, but do they have something like it, like akin to it?
So Malaysia, we usually have we have 3 main ethnicities, and those ethnicities have various religions, and we celebrate all of them.
Okay.
So that's why Malaysia has so many celebrations. So Thanksgiving is included. So if let's say we have a friend or relative that is Christian, or at least traditionally is Christian or Catholic, they would have Thanksgiving dinners and whatnot.
Interesting, because I think of Thanksgiving as like being an American.
Yeah, we celebrate Halloween, Christmas, and all that too.
Oh wow.
Okay, interesting.
We celebrate basically every
because America comes up with the dopest stuff, right?
Yeah. So
people gotta copy our traditions.
Yeah. I feel like it's more like because they carry it over. Because there are Christians in Malaysia. So I think that's the better way to put it. Is that there are Christians in Malaysia and they want to celebrate it too.
Yeah.
So since it's part of their faith, and part of the tradition.
You can't say that for Halloween though.
Halloween is just fun. Let's just be honest.
Did any of you guys dress up for Halloween?
When I was really young, yes.
Yeah.
But after we grew up, we just sort of like, oh, okay.
Okay. What was your favorite costume?
That's a good question. I remember when I was young, I dressed up as Spider-Man.
Okay.
The OG.
But what about you, Orion?
Oh, as a kid, I would just I had this really good one this one year. I got this old pair of jeans, and I had my dad light them on fire and burn them up. Okay. And I went as like a house fire victim, and that was pretty fun. My mom did my makeup. She had like my skin peeling and stuff. It was pretty cool.
That's actually awesome.
Yeah. My favorite was Zorro. I was Zorro for one Halloween.
That's pretty good.
Yeah.
That's pretty good.
That's awesome.
Yeah. And of course, I was stabbing people all night.
I think there was one nuance is that in Malaysia, it's rare that we do trick-or-treating.
Okay.
You just dress up,
go to people's houses and party. Like we don't
even the kids.
Yeah. We just dress up, just go to people's relatives' houses, eat, have fun.
Oh, okay.
But
nice.
We do give candies, but it's not like we go to door to door.
Okay.
I feel like that's more of a United States thing. Maybe some neighborhoods in Malaysia, but I'm not sure. I've never been aware of that. So.
Hello, space travelers. Want to look sharp while bending space time? We've got brand new Physics Society t-shirts. The clean graphic tee is just $20, and if you want to drop some Einstein-level wisdom on the back with this quote, "I have no special talents, I am only passionately curious," that one's only $25. Rep your curiosity, rep the cosmos, and support the Physics Society. Grab yours today before entropy takes over.
Interesting. Yeah, it seemed like there was more trick-or-treaters this year than there have been in the past.
Yeah, me and my friends went trick-or-treating. They knocked on the door, they opened up, it's just a bunch of college students outside. It's funny.
Did you dress up at all, or
no.
You just went as yourself?
We did. So we dressed up as some of us Harry Potter, some of us like just a lot of movie characters because we're lazy.
Yeah.
So we just went online, shop. Shop anything online that's like a movie character, generic enough. We just put it on. Go.
Interesting.
Anything for the candy, man.
Yeah.
So,
how was your week?
How was my week? Well,
Your 2 weeks.
oh my gosh, so busy, man. I'm finally getting to where I can actually study for classes. I was so busy during the semester with the different conferences, with physics society, with research, that I just hadn't really had a whole lot of time to like really sit down and study like I like to study. And so it's been nice because I feel like I'm actually prepared now for my finals that are coming up. Whereas, like, I couldn't have said that 2 weeks ago. Yep. I was kind of stressing, but it's all I need to focus on now is my finals. So I'm super pumped about that. And yeah, for the most part, it was. Oh, we had Senior Design 1 presentations. So I'm in Senior Design 1, and
when was that?
That was Tuesday.
Oh, I missed it.
Yeah. It was kind of.
Should have been there.
A little underwhelming because like we did it in the liberal arts building, and they have this huge sort of like theater looking room, and that's where we did it in. But there was like 10 people out there in the
normally they do it in STEM building, no?
Yeah, typically like STEM 101.
Yeah.
I don't know why they didn't like, again this year. Maybe it was taken up by something else. I don't know.
Maybe.
I mean, it was a pretty nice venue to do it in. It was just, like I said, a little underwhelming because of there not being many people there. But yeah, no, it was. You know, what's kind of crazy is we've given this presentation like 4 times now. So during Senior Design 1, you have to give your presentation over your project 4 times. Wow. Now, the first 2 are really just like, you know, you showing that you're, you know, starting to do the research and starting to look up like the different things. And then hopefully by your second to last and last presentation, you have like a prototype to show and things like that. And so, yeah, it's kind of interesting because...
Sounds stressful too.
It's stressful, but like at the same time, I felt like, I don't know, I felt like we could have got a lot more done this semester, but at the same time, we were told that like you really only have to make sure to get the idea, like what you're going to start building the next semester, which. Right. It's just like, so you expect us to build something in 1 semester? So I'm gonna start trying to build it over the break a little bit. Okay. And especially with how sort of there's a lot of moving parts to our project, right? So we're trying to build a Seebeck coefficient and resistivity measurement device.
Oh, was that the one I saw at the engineering birthday thing?
Yes. Okay. Yes. And so the issue with this is, for one, like I said, there's a lot of moving parts, and then 2, it's just really hard to measure these things, right? So we're putting this thing into a furnace, right? Mm-hmm. A tube furnace, and then our device is going to go in the furnace, and then we're going to have like a bunch of probes attached to the material that we're essentially analyzing, right? And then we have to try to measure the Seebeck coefficient of, and so the Seebeck coefficient or the Seebeck effect is essentially how well that device can essentially like create a current through it. So how well the electrons move throughout it, and so
at a given temperature.
Yeah. So what happens is whenever you warm up a material, the electrons start to get excited, right?
Right.
But then whenever you have, so if you just have the same temperature all throughout the material, they're just all excited, and there's no real
gradient.
Exactly. There's no difference of like more electrons on this side and less electrons on this side, which would cause a current. But once you start to add a little bit of voltage, or essentially you're adding a little bit of heat to one side, it creates that potential difference, which then causes a current.
Right.
But then we're also like, because you have this very tiny material, right? You're trying to measure the voltage at like a nanoscale or a micro scale, so like very small. And that's, unless you go out and buy, a device that can measure nano voltage, which costs hundreds of dollars, it's really hard to do whenever you just buy some modules from Amazon and and like amplify the signal. And so it's going to be interesting because apparently we're going to have to deal with certain issues like noise,
right? Especially at that scale.
You have thermal noise, EMF, and so that's why I'm excited to get it sort of going so that we can see like what the issues are that we're really going to be dealing with, because right now we're just sort of like in the dark.
That's the true engineering part of it, right?
I mean, you can read all day about these people who've, and there's a lot of papers of people who've tried to do the same thing, but some research papers aren't detailed about the things that they experience. They just show you the results.
Yep.
Right. Yeah. So it's going to be interesting to to have to work through those problems. But anyway, so I'm just so excited that this is the last week. We only have one more week from today. Yeah. So what I think, Orion, you said you didn't have any plans for over the break, just the winter, sort of chill, or
nothing specific. I'm probably gonna get out there a little bit, go out and do some fun stuff with my friends. Yada. Maybe do some like go on some little Christmas trip or something. Yeah. But nothing's set in stone yet. So
other than like playing jazz, do you have like any other hobbies?
I like to play Balatro. You know Balatro?
No, I don't. I have no clue what Balatro is.
It won Game of the Year.
Okay, I gotta look this up.
I'm not sure what year it was. I think it was a couple years ago now. But it was like
Balatro, like that. Oh,
Balatro game.
Oh, the third one.
Oh, okay, gotcha.
Oh,
okay, it's a card game.
It's a card game.
Yeah, I played too much. Actually, too much. I almost said a whole lot. No, too much is much more accurate.
Looks fun.
Do you have it on the PS5, or you just have like the cards? Or?
I do have it on PS5. It's not a physical card game, sadly. Yeah. But I play it mostly on my phone. Too much on my phone, actually.
Well, what is the game?
So, if you've ever played poker, it's sort of like you combine poker and solitaire. Okay. And then add on like video game things, like put a shop in there, put some little modifiers you can put on and all that stuff.
Okay.
So you make you make all the poker hands and stuff, and you get points for it, and then you can you see those cards that it has displayed, those are called jokers.
Okay.
And like the plain looking one right there up front just adds +4 to your multiplier.
Okay.
So it's just like, just fun little game.
Yeah, so over Thanksgiving, my mom gave us this new game to play. It was called, what was it? Uno. It's a new kind of Uno. Oh. It's like Uno Extreme or Uno, something like that.
Yes, it has a lot of different power cards, right?
Yes, exactly. God, so there's... You've played Uno, right?
Of course.
Yeah, I hope so.
I have that actually.
So this one though, there's like a card that's a 7, but it's not really a 7. It's you can swap hands with somebody.
Oh, I think I've seen that. I've seen that one. Yeah.
And then there's this one where you can make somebody draw 10.
Yup.
And then you can stack draw cards. So if somebody puts down a let's say a draw 4 card, right? Mm-hmm. Then somebody else can put a draw 4 down. And then if somebody has a draw 6, they can put that down. And if somebody has a draw 10, you can then put that down. So you can so somebody can end up, drawing 100 cards.
Damn. Yeah. That would be a bad way to go out.
Oh my gosh. And then there's this one card that makes, so whatever direction you're going, right? It makes you swap with the person next to you. Mm. So everybody swaps cards.
Oh, wow.
Yeah. It's a super tough game to try to win. Man. And it seems like there's no strategy. Because just when you think you've won,
people swap cards with you.
Yeah, exactly.
Yeah. But speaking of card games, over Thanksgiving, I got introduced to Magic the Gathering for the first time. I know what it is. I've just never played it.
Have you played Magic?
I know it's like Yu-Gi-Oh. I know that Yu-Gi-Oh is kind of similar to Pokemon, and I play Pokemon.
It's the first time I played it. It was pretty fun. But it's still so hard to learn. Like every card has its own unique thing. It's just you gotta learn along the way. It's crazy.
Yeah, there's tournaments in Oklahoma City.
Real world tournaments. Yeah.
My brother-in-law goes to them. He loves it, dude.
Does he win?
That is so it's so fascinating to me that, like, for one, like, we're talking about Pokemon, like, some of those cards are worth like hundreds of thousands of dollars.
Yep. I got a friend, I was just actually over at his dorm earlier today, but he has a full binder of like holographic cards and all this crazy stuff. He pointed a couple out to me. It was like, oh yeah, this one's like $180 on market right now. This one's like $300.
Yes, my friend just recently went to a Pokemon event back in Malaysia, right? They have these lucky draws. If you like, you buy those packs, you open them, you get the cards, right?
Right.
He got one of the $300 ones. I don't know what they're called, but like it's from the Evolution pack. Do you know that one?
I know the pack that you're talking about, but I can't think of the card.
Yeah, but it's one of the cards. Pretty cool.
It's kind of wild, man, because I'm a little bit probably older than you guys, right?
Hey, you're never too old to collect or play.
Yeah,
okay.
No. But like, whenever I was a kid, that's when Pokemon first came out.
Yeah.
And to see, like, I remember like getting up Saturday mornings and like just laying on the couch and watching Pokemon for like a couple hours or whatever. And then now, like years later, it's still huge.
Yeah. I mean, it really does bridge generations. Like, Pokemon's been going for a long time now.
Yeah. I used to play the video game on the my Game Boy.
Yep.
I was the apparently, that's what they told me anyways. I don't know. Maybe they lied to me, but I was apparently the first kid in Oklahoma City with a Game Boy Advance. You remember those? The square or the rectangle looking ones.
Yep.
Yeah, dude, I played so many hours of Pokemon on that. But yeah,
isn't there like six generations or something of Pokemon right now?
I don't know. It might even be more than 6.
Really?
But it's getting pretty up there.
Yeah, I know there are like 9, almost 1,000.
And it's still Pokemon? Ash Ketchum, right? He's still like the same age, apparently.
No, he is older now. In the most recent series, he is older.
Okay.
Okay, that's cool.
I love that when like anime characters just never age.
Yeah, pretty fun.
Oh, there is Generation 9 now.
Yeah.
Wow.
Does that then how many Pokemon are there now?
10 billion.
No.
That's insane. That would be insane. It seems like there's an infinite amount of different Pokemon.
1,025 different Pokemon.
All right. Well, I say we get into this topic.
Yep. Let's get back into the science.
So, okay. So you said you got into jazz when you were like 4, you said?
Grade 4.
Grade 4 I got into bass.
Oh, okay.
I want to say like freshman year in high school I got into jazz.
Okay. Oh. And then when did you start maybe thinking about it mathematically or physically, like?
You know, it took a while because I didn't know, like whenever I started, I didn't really know anything about music theory. And that's where all the numbers come from. You know, like the intervals, like minor, second, all that stuff, all the actual numbers, that comes in music theory. And actually, I've never taken a music theory class. But,
are you planning to?
Yeah, of course.
Okay.
But it's just sort of like things you pick up here and there, you know, like different instructors who go a little bit more in depth about it. And it's just like all these numbers coming at me. It's like, I like numbers, you know. I do math. I enjoy math. I got a 5 in AP calculus, dude.
Heck yeah, let's go.
Yeah. So I really, you know, sort of brought to my attention that like there's a lot of crossover between math and music and physics and all this stuff. Like whenever you look at it from a certain angle, it just all lines up. So
yeah, I'll be honest. Like I think the most daunting part about it, right? Because you know, I think the fractions, right? Just, I mean, adding fraction, multiplying, like that's to me is one of the easiest things to do. But whenever you go and try to look at the waves and trying to see how the waves are interacting with each other. Like that, it just feels totally abstract. So have you dove into maybe some of the wave mechanics behind it?
Wave mechanics, I mean, not past like an intuitive point. Like, of course, I've seen like visualizations and all that stuff. Like, I've been to the Science Museum, right?
Heck yeah.
But it's really just like a lot of it is just sort of intuitive to a point. Like, a wave hits a wave. Like, you can see that you can throw two rocks in the water. You can see like what it's like whenever waves hit waves.
Yeah.
So it's like for music, it's just. Like you hear it rather than see it, right? So like dissonance, like the different peaks, like you see two waves hit each other in a pond. You see the peaks sort of oscillating, like I don't know, like what's a good example? I'm trying to remember what the Science Museum demonstration was, but I can't quite remember. But like you have like a strobe light behind a string, and you pluck the string, you can see the string waving at like whatever frequency, relating to the strobe light.
Yeah.
So it's like all this stuff is just sort of like it's intuitive in a way, but it's also like you need to be able to imagine it, right?
Yeah.
Like you need an example. So for me, it really came when like whenever somebody explained it that way. I think I read like an article or something. It was like relate like specifically about waves. I can't remember what it was, but I don't know, it's just all very interesting. I don't really know the wave math, especially with music. Like a note isn't a perfect sine wave, right? It's not it's like they're never gonna be perfect waves because instruments are physical things in the real world. Like you're gonna pluck it differently, it's gonna bend, there's gonna be like little different things that affect the wave, right?
Yeah.
So it's not as exact as like actual like studying like waves the way that you mentioned, but
yeah, it'll be so for instance, like what we learn in signals and systems is that a lot of the sounds we hear are, so you think of a sine wave, right? But a lot of them are like a bunch of sine waves put together, and so with like different amplitudes and things like that. And so that's what the genius of Fourier was, is being able to break down a complex signal or complex wave and then show exactly like what each what all the frequencies were in that signal. And so I don't know, like what to you is really the most interesting part about all of this?
So I like the idea of like dissonance, dissonance in a lot of things, because like about the gravitational waves from black holes and all that. Like you can there's dissonance there, like this black hole's putting out these waves, this black hole's putting out these waves, and they sort of collide, and it's like super low frequency sound and all that. Like it's just, it all sort of relates to each other because everything is a frequency. Based certain theories say at least that every single thing is a frequency.
Harmonic oscillators. Do you see that meme I saw the other day? Is that physicists be like, oh, everything's just harmonic oscillators, and then the other guy's like, always has been. I feel like everything we learn in physics has some aspect of harmonic oscillators to it. It's just very interesting how the same rules apply to almost everything. And now in quantum mechanics, even wave functions, you need to learn about like how wave mechanics work.
Yeah, it's just so crazy. And then you think about, apparently Kepler thought about the orbits
in harmonic oscillator.
Yeah, exactly.
Because it's periodic.
Yeah, and I'm just like, well, he had to have a good intuition about music, which
Yeah, that's true.
I wish I had.
I have to admit, I cannot play any music, like any musical instruments, even if my life depends on it.
But what's kind of cool is UCO on the 4th floor has pianos that you can actually go and play. You have to apparently put in headphones, but you can go up there and play them, which is like,
you can even play them in the music building.
I think I'm going to start learning how to play the piano.
You know, if there's an instrument to start on, it's piano. I definitely made a rash choice when it came to bass. Piano is definitely like the much better fundamental.
Interesting, huh? So, are you able to tell us about the physics of the bass?
So bass, it's sort of like if you want to think of like a root tone, like the lowest. Like you were talking about, every sound has multiple frequencies. Typically, bass would be like just the lower register of those frequencies, right? Like so a chord is built typically like a major chord. Just the most default chord is the first note of the scale, the third note of the scale, and the fifth note of the scale. 1, 3, 5. So the bass always plays the 1. It is the fundamental tone. It essentially is like the name of the scale. So if I'm going into the physics of it, which I'm not qualified to do, by the way.
Yeah, it's fine. None of us here are experts. So
it would be like the bass is the one that sets whether or not there's dissonance. So like if imagine you're in like a 3-piece band, right? Like you have a bass player, a clarinet player, and like a trumpet player. And so the bass player plays the root note, and then the clarinet player plays the third, right? And then the trumpet player plays the fifth, right? And so if the clarinet player...
You say right, but I really don't know.
Sorry.
No, I'm just messing with you.
Okay, so...
I went over some of the physics of the different instruments, but I don't know. Just giving you a hard time,
Okay, so the bass player plays the root, and then imagine the clarinet player plays... So I was explaining intervals. It plays, rather than a major third, it plays a minor third. So that's 3 half steps. So like da 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 da, and if you play that minor third, there's going to be more dissonance there than if he had played the major third. But it's only because the bass is playing that note. Like if you just had the clarinet and the bass, and they were playing third and minor third, the dissonance comes from the relation to the bass.
Oh, okay. So, like, whenever you hear an orchestra, right? They're all. I mean, of course, you think they're all working together, right? But it's even deeper than that. Like, so depending on like the notes that the woodwinds are playing, it depends on what maybe a bass would play.
Right. It all has to relate to each other. Yeah.
Oh, wow. That makes sense. No wonder a symphony is so hard to write.
Yeah, right.
Like if you just throw one wrong note in there, that dissonance, like it sticks out like a sore thumb. Like to a musician or just to anybody, like if it's stark enough, like you can just hear it. It's intuitive.
And it's annoying.
Annoying, yes.
Yeah. Well, that's what's weird is that like different cultures apparently have different. Well, for one, there's they have so different cultures will have different tones that they that are more prevalent in their music than others. And so it's fascinating that like the Western music is like, I think they say like 12 chords, and then there's like some Chinese, what was that, gamelan? I think they said that has like 24 different and
I believe it's 12 pitches, no?
What's that?
For the Chinese thing they go.
And I think they said 22 or 24.
Oh, really? That's crazy.
They have double the amount of Western music or whatever. And then there's some like in India where they only play like 5 chords.
I've heard about Indian music theory. They think about it almost entirely differently. Like they have Am I able to use the whiteboard?
Yeah, go ahead.
Go ahead. Yeah,
We should work.
usually we have one standing one right here, but
there we go. That works.
we don't have it today.
Okay, I don't want to.
Yeah, you're good. No worries. Yeah, if you need to take off the headphones, no worries.
So if you really like, if you're looking at like classic Western intervals, it's like line, like 1, 2, 3, 4, perfect fifth, like all this stuff. And then if you look at like Indian music theory, it's sort of like it goes up and dips down a little bit, dips down a little bit, dips down a little bit, and it just kind of follows that pattern. So their intervals have like their own sort of wave function to them. Like every single interval has that tune. But I'm not sure if it's all, India is a very big place.
Yeah.
Billions of people.
They have a lot of subcultures.
Yeah, a lot of subcultures, a lot of different ways. So I'm sure that a good amount of them do, that sort of music theory. But I know for a fact that their intervals are designed differently.
That's very fascinating.
So it's not a standardized thing. Music theory is like, it's called theory, like a math theory or like a physics theory, but it's a lot more subjective than any of those.
It's very arbitrary because it just depends on where you start labeling the first tone and the next.
Yeah, and so apparently this. So what do you call it? 12 notes or 12 chords or 12?
So there is 12 tones.
12 tones. Okay.
And then there is so many major scales. I'm embarrassed now because I can't.
No worries.
Can't remember all my major scales off the top of my head.
Well, so apparently these 12 tones come from what's called equal temperament or temperament. So it's a system that divides the octave into 12 equal parts, and so they use this ratio 2 to the 1/12 for finding each subsequent tone. And so this was apparently, I don't think Bach was the one who invented it, but Bach was definitely one that used it, one of the first musicians to use it and sort of show that you could use a full piano, and that a piano could be tuned in such a way that you could play all of it and that all of the notes would be consonant. And so that's where he gets the I think it was called the well-tempered clavier, which is like apparently like a 3-book what do they call it, prelude or fugue or something like that, like literally has like 3 basically full albums of him going through and showing essentially what this is him going and showing that you can play the full piano, and it's really beautiful. Let's see here. I want to play a little bit of this so Albert can hear it. Let's see here.
So it's like the tempered scale.
Yeah, let's see. What is it called?
Well-tempered clavier.
The well-tempered. Because as soon as you hear it, you're going to be like, oh, yep, that makes sense. Or, yeah. Oh, did it turn off?
Battery, high.
Huh. I'm sure you've heard this before. See if I can turn it.
Oh yeah, definitely heard this before.
But yeah, this one apparently is like he starts in C, and so I don't know if it's true that this whole song is in C. Like, whenever they say that, they say
something in C major or something in C minor.
Yeah, does that mean they're like every note is a C, or is it you're playing around the C? Or
so essentially, music is broken up into keys, and these keys have different intervals. So every major scale follows the same pattern. It's half step, whole step, half step, whole step. Oh wait, no.
And that's on the piano.
Sorry, invert that.
Yeah.
Whole step, half step, whole step, half step.
Okay.
So on the piano, that'd be like white key, white key, white key, black key, white key, white key, white key, black key.
Okay.
Something like that. I really should have brought. I thought about bringing like my electric bass just for demonstration purposes.
Yeah,
but
no worries.
that would have been a good
Next
idea.
time. Yeah, that was the next time.
So every single key follows the same pattern, but because it follows the same pattern, and you throw in a different note, it has a different sound to it, right? So like for C, that means that there is no sharps, no flats. So essentially, it works out to be all white keys.
Okay.
And like if you were to go in one direction and add a single sharp, like you would be playing a G scale. So like that would be only F sharp. It goes in an order. I can't remember like what the relationship is between like the actual notes that become sharp or flat, but it's like the wheel of fourths, fifths. I'm not very qualified, guys. I'm not sure.
No, you're good. No worries.
You definitely could have picked somebody better to explain this stuff.
I'm enjoying this.
The whole point of this podcast is to have both students and faculty share about what they're interested in. It doesn't. We're researchers for a reason. You know, we're researching. We're trying to learn what we don't know.
Right.
And the best way to learn is to discuss and talk about it and look into it. Along the way.
Yeah, we can always Google it if you.
I feel like this is more candid, more honest.
So playing in a certain note, so playing in C, you're playing around us, like say you're playing in C sharp, right? So are you only playing around C sharp? Is that what it is?
So if you're playing in C sharp, you would only play, or not necessarily only, but typically you would play notes that are only in the scale of C sharp. Okay. So like those half steps and whole steps within that scale, you would stick to those.
Oh, okay. Yeah.
So
that makes sense.
it gives it a consistent sound and all that stuff. You know, every once in a while, like if you're getting a little bit wild, you might put an accidental. So that would be like you put a specific marking, like a sharp as the hashtag sign. Flat has a little B. And that would mean that note specifically is changed to be outside of the normal scale.
Okay.
And then the next measure would be like, it would go back to normal. Okay. But it's just like, you stick to that general area. And like, there's chords that fall into scales, and I'm not really sure how all that works, but like, it all follows like a progression necessarily.
I see.
But so like, sometimes a chord will have a note that's outside the scale, but the scale itself is still like the base of the song.
I see.
Yeah, that's cool. Because there are musicians that embrace the dissonance, right? For example, is it Beethoven that loves in his music add in a bit of dissonance in there?
He does.
Yeah, and I think the reason for that, right, is just to sort of
express, like, for example, like Good Times, he'll like emphasize more on the harmony, and then the dissonance part would be like, oh, terrible things happening. Right.
Well, yeah, and then, but even in just the like what I was reading earlier, in just on the piano and making sure that all of them sound good to your ear, consonants, right? Even each one of those, like A, B, C, D, E, F through G, like give you a certain sort of emotion as well, which is interesting. And it's like, what is that, right? Like, I mean, of course, you think of like a very high pitched tone, like
a major,
sort of like a happy, right? Like, and then but then a low,
minor tone
is like sad or like.
Right, I know there's a lot of sad music use minor chords. Am I right, or is that the other way around?
No, that's accurate. That's accurate.
And I wonder what that is. Like, what is?
I mean, well, so remember I was talking about like each one is a fraction of like if it's undertones and overtones, right? I'm not the most qualified to explain undertones and overtones, but it's like every note has its bass tone, what you call the note, and then depending on the instrument or like the medium or whatever, it has different overtones, so it has different notes that it might match up with. So whenever you play a minor, it's like a minor chord. So if I'm explaining a minor chord, it'd be like So I said 1-3-5 is the basic chord, right? A minor chord is just lowering the third by a half step. So that turns it minor, regardless of any of the other notes. Lower the third. It becomes a minor chord at a minimum. And so whenever you have that minor chord, it increases the the fraction becomes
the numerator,
larger.
the denominator.
Yeah, so the
difference gets larger.
Yes, the difference is larger. Here, I have actually I have a specific example. So.
Oh, the ratio gets larger. I see.
Yeah, I was watching this 3 blue 1 brown video this morning.
Right.
That was talking about the different ratios that correspond to different tones, and I'm just like, wow, it just feels so abstract to me.
No. Weirdly enough, the problem is it's intuitive because. That is what it is, it sounds like that because of it, but we cannot imagine that in numbers. But it is.
But then at the same time, why do
the relationship,
certain ratios or certain numbers give us certain feelings?
Actually, I've read a paper about like a year ago that talked about how why we evolved to like music. At least the one I read is specifically percussions. I'm not sure about like melodies and whatnot, but they said that they did experiments of beats, and they realized like a certain beat. You know how some beats will make you like feel more energetic, like for example the bum 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 bum. Those type of beats.
Some house music.
Whatever beats like those are more upbeat rhythms. You will feel your heart rate will start increasing. They found that babies. When they're in the mother's womb, they can actually feel and hear the mom's heartbeat, and they found that they respond to that, and usually and they can replicate that using like speakers or like some resonators for adults. When we hear certain beats, that's similar to a mom's heartbeat that's racing, we will feel the same like emotion. So it's basically to get us to get ready, brace for something's gonna happen.
Well, it's also like on Spotify, you can look it up like if you can look up like study tones or study
calm music
frequencies,
like a brown noise,
certain frequencies,
yellow noise for focus.
There's this like certain playlist that I have. Where is it at? Oh crap! Where is it at? But anyway, it's just like it just plays you different frequencies. I think it's like around 440 or something like that. And it's supposed to help you concentrate better.
I've seen those.
I'm like, what is the logic behind that? What's the theory behind that? Like how certain just frequencies can just make you feel a certain way, right? Because there's like some people who, there's certain frequencies that like I've heard that windmills can put off that can. I don't know how true this is, but apparently it can make people go crazy. And there's been like in torture techniques, right? They will play you metal. Well,
I've heard of it.
Yeah, and like really loud, right? And apparently that makes people go crazy. And it's just, I don't know, noise and sound is just so fascinating to me. Just more or less because of the impacts it has on us, right? Like I listen to music all day, every day, and part of the reason is to help keep me motivated, right? I'm like, that's why I like listening to hip hop music, right? And a lot of the hip hop that I listen to is like more upbeat and like, I wouldn't say like party music, but like
rap pop almost.
Kind of, yeah. I listen to like a lot of Trippie Redd.
I see.
And you're not listening to Trippie Redd for the, sorry Trippie Redd, but you're not listening to him for the lyrics, right? He has more of like a sound that to me like I resonate with. And I just find that so fascinating because like there's times where I do want to listen to like some Beatles or whatever.
Yeah, sometimes some AC/DC will get you going. And then sometimes just normal pop music will work, or sometimes the classical music. But that's an interesting thing that I also found is like sound that we can't hear, like infrasound, which is too low of a frequency for us to hear, can cause real physical effects on the human body too.
Really?
Yeah.
You know the sick building syndrome, where some people when some designs of a building, when you go in there you'll feel sick because it's not feng shui or anything, right?
Yeah.
It's actually because the way all the equipment like air conditioning and all the electrical stuff, they start humming, right?
Yes.
And the humming starts building up in the building, but we can't hear it. But since a building like a cavity is a resonator, right? The infrasound start resonating with literally resonates. They found that our eyeballs or something can resonate with like 18 hertz or something. So it'll cause like headaches, dizziness, and even starts disrupting heart function and all that.
Interesting.
So sound that we can't even hear can affect us. The same way infrared is a light that we cannot see, can make us feel heat, you know?
Yeah.
It's pretty interesting. I just found it so wild.
I can't remember if it's like a movie or like an actual real thing that I saw, but it was like a barf gun where they just shot like a certain a certain frequency of sound, and it will just resonate in your like in your
your vestibular system.
and it'll just make you feel sick.
Vestibular system.
I brought these glasses for comedic effect. But
whatever, biomed boy.
That is so funny. A
crazy.
barf gun, though.
That's
Oh
cool.
my god, I'd be so pissed if somebody used that on me.
I mean, it'd be very effective in like a time of war, you know. Hard to shoot if you're like off in the corner, right?
Yeah. I mean, there are like sonic weapons, right? They use that to like knock out like. Was it like drones or something? Oh no, those electronic warfare. My bad.
Well, and then there's also, apparently. What was that during the Cold War? When we were having issues with Cuba and Russia, right? Is that the Cold War? I can't remember.
Yeah, that's the Cold War.
Okay. And apparently the CIA had developed this like cancer gun. That,
I heard about that.
Yeah, that could like give you cancer based off of some like frequency or something like that.
Maybe it's radiation, no?
It makes sense, but but what kind of radiation gives you cancer after just one?
Just one big exposure of a lethal dose of like
uranium.
You're gone. Organ failure. That's crazy.
Yeah, and so I've been trying to study more about wave mechanics, and I've taken all these classes, signals and systems, digital signal processing, but I haven't really taken the time to like really think about it. I just like sort of just I've been so goddamn busy that like, I just trying to get the homework done, do enough to just pass the test and everything, but I haven't been able to just like sit down and like really imagine and like analyze what's going on. And I don't know if that's like an issue with me giving myself too much, or also at the same time like an engineering degree, right? They tell you like take 17 hours a semester, right? And that just doesn't give you enough time to really think about these things, which I don't know. I think if you really want to be a good engineer or even a good president, right, you need to be able to like think deeply about a lot of different topics, right? Innovation happens at the crossroads of different disciplines, right? Because to me, and I know Albert, like one of the most fascinating topics is quantum mechanics. And really how you get the most out of that is by, being able to deal with the Schrodinger equation. And that's a wave equation.
Half the time I still can't deal with it.
Yeah. I'm just telling you, and so, I'm like, okay, this break, I'm going to like dive into some wave mechanics and really try to understand, what happens when you mix a bunch of different frequencies together. Because it's kind of wild that like every day we have like different frequencies just flying past us all day, every day, right? We probably have in this room a bunch of frequencies going all over the place, and yet we don't think about them.
True.
And two, I just think it's so fascinating that like you can think of all of the most deepest physical phenomena as waves.
Yeah, pretty incredible. I don't know, isn't that what string theory is? Like everything is like a little
string,
little vibration.
Yeah.
Albert has a feud with.
You're not a fan of
string theory.
No, string. I still call it the string hypothesis, bro. Like because people call it string theory, but I don't call it a theory because it's not proven. Mathematically, it's beautiful. And it's one of very convincing theories out there, but one of the greatest proponents for it, like the evidence for it, is supposedly supersymmetry, which is or SESI, if you know supersymmetry, the short form. And the CERN already scanned through a specific energy requirement for it already. They looked through the entire energy scale and they found nothing. The right way to think about it is that they already clear out a lot of different kinds of string theory. The problem with string theory is there's so many different versions.
Right.
That's why I feel like it's too arbitrary.
So what is the like basis of string theory, right? Is it literally just everything's connected by some strings, or
so more like it's more like they claim that every elementary particle we have, every field we have in the universe is the same string. There's originally like 27 dimensions or anything, but now they've reduced it to 7 or so. Basically, they vibrate in those different dimensions, and depending on how they vibrate, they create different properties: charge, spin, mass. Depends on their vibrations. That's why if you ever hear the string theory landscape, which is basically says that there's 10 to the power of 100 or 120 different types of possible string theory configurations. That's why they say, string theory multiverse, different conditions and whatnot. But no, I still call it hypothesis not because it's disrespect in the sense that it's a bad theory. I just don't think we proved it enough to call it a theory. It's a hypothesis. That's it. I'm not trying to like throw shade at string theory. It's a beautiful theory. In fact, one of the reasons string theory was so like caught on so many scientists' attention is because at some point when they solved the equations, right, they found that a spin 2 boson came out of that equation, and spin 2 bosons shows a property similar to gravity. So they're like, oh shit, maybe we just solved gravity now. No, they haven't.
No shot.
Yeah, so.
Yeah, gravity's a weird one. It just seems very elusive. Yeah. Is it even real?
Or some argue it's a fictitious force, but if you look into it, right, you know how we have two types of waves: transverse waves, which is things that oscillate perpendicular to the wave's motion, and that's like a rope when you whip it, or just an earthquake, or just a water wave, right? A displacement wave. But a longitudinal wave is the sound wave, right? It goes in parallel to the motion of the wave. Sound waves, right? It's also a displacement wave. But gravitational waves, they call it a tensor wave. It's so hard to visualize because they, instead of displacing like this or like this, the displacement is like a squishing and stretching motion of like
3D.
Yeah, can you pull it up? The tensor wave. Yeah, I just want him to see that. It's pretty interesting. Tensor wave.
That's the keyboard, man. So that's pretty good.
Oh, I appreciate
love
it.
that keyboard, bro.
So
I was tempted to buy it the other day.
yeah, because you know, some professors talk really fast, and I try to get down as many notes as I can. I feel like that's part of my studying is trying to just pay attention like really hard in class, and so I'm trying to just make sure I get everything that the professor's saying, because sometimes they'll say something that's like you really need to know, but they just sort of like
Skim through it.
Yeah, and so I can go back and sort of look. So I'm like, I'm a really fast typer, but a really slow writer. So sometimes when they're just talking, I like to. But then I at the same time, I didn't want it to be like real talky and real loud. So I made sure to find like the most silent
Keys.
Yeah. Yeah.
While being sound like.
Yeah.
So tensor wave. Go to
images.
Images. You go down a little. Yeah. So tensor waves.
This thing.
Yes. So it looks like that.
Oh, what the heck? There we go.
Yeah.
After clicking 4 different things.
well, just search gravitational wave. They have better. Because
so
yeah.
which one's a tensor?
That's the on the right. It's called quadrupole radiation because instead of oscillating with 2 poles,
Yeah.
they oscillate with 4. 4 different poles, and that's why LIGO has 2 arms. You know, LIGO, the gravitational observatory, the detector. They have 2 arms because it displaces in 2 different ways, and that displacement helps us determine where the wave is coming from. So
see, this is weird. It looks kind of like the what are they called? The electron orbitals. Right? I mean, there's not an orbital. There's not an orbital like this, but
I mean, the Bohr model says, at least the original Bohr model says that the orbitals are just standing waves for the electron field.
Let's see here.
Yeah.
Oh my goodness.
They're standing waves.
I wanted that first one. Oh,
Yeah. That's the hydrogen wave function. Yeah.
Yeah.
Which is crazy how you with that equation. That equation looks simple, but it's very complicated. But that equation can predict every orbital a hydrogen has.
Wow.
Schrodinger's a genius, man.
Yeah, I mean, look, this one looks like this one. Huh. Does it not?
This one looks like it sure does. It sure does. You are right.
Yeah, it's kind of wild, isn't it?
Yeah.
I wonder if there's any correlation there.
Yeah.
I'm gonna take a screenshot and I'll ask ChatGPT later.
Yeah.
You know, that's what it's all about, man.
Yeah.
Gemini, bro. That's Gemini.
Do you use any AI?
I used to be big on ChatGPT, but I've moved more towards Gemini just because it's right there whenever I'm googling. You know?
Okay, yeah.
Wait. Can you just search up
Gemini is really good.
Yeah.
Can you just search up gravitational wave and then write tensor wave?
Okay.
Yeah, I think that just gravitational wave then tensor wave.
Oh.
Gravitational wave and then tensor wave.
Oh, and tensor wave?
Yeah, and tensor wave. Just write tensor wave.
Oh, wave.
Go to images.
Okay, let's see here.
Why are you using Bing? Yeah,
that's a
better.
great question. That's what I've been wondering. Too.
yeah. Because
So the reason I use
Bing?
Microsoft, right, the Internet Explorer, is because of this right here. I love the vertical tabs.
you can get that in
Google doesn't have
Opera GX.
No.
Yes, you can.
Opera GX. Yeah,
That's
I don't
setting
like
for
Opera
it.
GX though. I tried it and I don't like it. I'm sorry.
Fair enough.
I'm not that big of a nerd.
But you should be able to find a GIF or GIF, depending on how you read it, that shows the distortion that is
between them.
I don't know why you don't have that. I have that right here.
Yeah, let me go to Google.
See, I found it.
All right, let me. Do you do it from Google or?
Yeah, Google.
Okay, yep.
See, you can see. That's how the wave looks like.
That's like gravitational wave?
Yes.
Wow.
But imagine in every direction.
Which one?
See, that's the hardest part for me. Like, whenever I'm thinking about, like, black holes and whatnot, like, imagining it just in all directions. It's kind of like...
Well, it gets trippy if you realize, because you know how light...
Let me see this. Which one is it?
This one? This one.
Oh, okay.
It looks like a worm wiggling.
The Bing had that one. I don't want it. I don't want to hear it. See, watch.
No, but does it have the GIF?
Oh, a GIF. No, it had this.
Yeah. No, I know. I saw that, but it's not a GIF. But yeah, it still demonstrates what I'm trying to say. But if you realize the EM wave, it's this. It's also this, right? But it's in every direction because it's multiple of it.
Right.
So I don't know. It's just pretty fascinating how like the wave mechanics. As science develops, we understand more and more about wave mechanics, but we discover more different kinds of wave mechanics.
Yeah.
So
that's what. So I shared a video on the Discord yesterday about how Schrodinger derived the wave equation. And it's just so fascinating because he first just sort of thinks about a flashlight, and from there he goes from I believe uses Lagrangian mechanics to then go derive his wave equation, which to me is so wild. Like sometimes when you can see these derivations, it makes it seem possible for another person to do, right? Like, I mean, of course, Schrodinger, he definitely was a brilliant man, but also at the same time, like people talk about geniuses all the time, and our favorite quote here is from Einstein. He's like, "I have no special talent. I'm only passionately curious." And Einstein didn't feel like he was a genius. He just felt like he just spent more time than anybody else on a certain problem, and so yeah, it gives me hope that I can just like spend a lot of time and maybe I can like come up with some cool equation that people will use.
I do have a few channels. I do have one channel if you guys really want to dive deep into quantum mechanics and wave mechanics.
What's it called?
Dr. George SDS. So you just type Dr. and then J. It's Jorge. So I don't know.
DS. S
space DS. Yeah.
Oh, there he is.
That. So he will show you step by step how every physicist and scientist came up with the thought experiments, all the experiments, and how they derive each equation.
Okay.
From Einstein to Heisenberg to Schrodinger, everyone.
I think like
this guy's helpful. Very helpful.
Math textbooks need to have this.
Well, they do. It's just that they don't visualize it.
Yeah.
This guy helps like visualize it. He explicitly tells you this part is what, that part is what.
J.K. Not.
Yeah.
Okay.
No, seriously, his videos are so underrated. I really think more people should watch his videos because he also emphasizes what it means, what those equations and all those variables mean. Yeah. What they imply.
Interesting. So,
and
Orion,
he takes away the myths of quantum mechanics. So
I think we need more of that, right? Like so many people are afraid of like math and afraid of physics because they're afraid of the math, and it's like it's just a matter of time. Like all you have to do is spend a little bit of time on it and you'll get there, right? And then nowadays there's so many cool YouTube videos to go out and check out and that really break things down in an intuitive way. But is there like a certain part of physics, like a certain branch of physics that you find most interesting?
Whenever I was younger, I watched like Nova and stuff like that. Like Star Talk. Yeah. That's one of my I don't listen to podcasts, but I like Star Talk a lot. So Neil deGrasse Tyson.
You don't listen to podcasts?
I mean, not a whole lot. Okay. I mean, more of a music guy. I'm a music guy.
Fair enough.
But I used to be really into what is it? Like astronomy and all that.
Okay.
Like astrophysics and whatnot. But eventually I started moving away from it because I was like, well, Einstein was a theoretical physicist. I want to make something. I don't want to just like look and say what's happening. I kind of want to like make something.
Yeah.
So I started moving towards theoretical physics. Of course, this was all in my mind. This was imaginary. I was not actually like super deep diving into any of this stuff.
Okay.
But I was just like,
you were
the idea
pondering about it.
Yeah. So that's sort of where I'm at right now. Like if I were to do something with physics, it would be like on the theoretical side.
Okay.
But really, all of it's just super interesting, man. Like quantum mechanics is all. Sorry,
No worries. It's all good.
But it's just like super cool, you know. Astronomy is still super cool. Like black holes are like the coolest thing I could think of.
Yes. Yeah, that's what we have. The black hole, man.
Yeah.
Because I mean, we think. I mean. There's this weird thing, right, with like living in a city is you don't really you're not able to look up at the stars and actually see the stars very well.
So true, man.
And so I think I'm really going to build this thing, and which is essentially like a way to gaze up at the stars and like eliminates the
light pollution.
The light pollution, and then it'll have like essentially AR, augmented reality, so that it'll show you where all the constellations are and things like that. Because I think we need to be able to look up in the sky and like wonder.
Absolutely.
Right?
Absolutely.
I think a lot of our imagination comes from that. A lot of our thinking about our future comes from that. Right? And whenever I look up at the stars, I'm just like in awe. And that like feeling of awe makes me feel like almost as if like there's a higher purpose out there for me, right? I know that can sound cheesy, but like I really feel that. You know, I felt the same way whenever I went to DC for the first time. And you're in these like old buildings and you see all these like old statues of old people, right? Like Thomas Jefferson and like just these, you know, greats that helped form the United States. That, I mean, yes, they were flawed, but at the same time, like they were revolutionary in their thinking, and they were thinking big, right?
Very much ahead of the time.
I bet a lot of that was because they didn't have light pollution, and they were able to look up at the sky, and I think that's a lot of why we're here now, and we have this like very futuristic civilization is because we were, you know, our ancestors looked up at the sky and like were able to just dream about this technological future that we're in and that we're also trying to move into. Mm-hmm. And I think I really think we're missing that. And so, you know, that's why I want to build some device so that we can be able to look up at the stars like that. One of the coolest businesses that I saw recently was this guy he has this land in Texas. Mm-hmm. And where he's at in Texas, he's like in a very it's like out in the middle of nowhere,
like a rural area, like a big old plot of land out there.
Yeah, exactly. Okay. And he has this huge garage, but what's cool about the garage is the roof comes off of it at night. And then once the roof comes off of it at night, you see all these telescopes in there that people have bought and sent to him. And he rents out the space to be able to put your telescope in, and then you can actually get online and apparently see the images that are coming from your telescope. And I just thought that was like super innovative.
Yeah, that's pretty awesome.
You know, but also a little sad though, right? That we can't just, because for like people can't put telescopes out in big cities anymore because of the light pollution. Oh. So you have this thing that's like, you know, made specifically for looking up at the stars, and you can't even use this like high resolution telescope. It was made specifically for looking at the stars because of the light pollution. So you have to go and send it somewhere else to be able to see it. I mean, I still think it's cool that you're able to do that.
Right.
But also at the same time, like, we shouldn't have to do that. But also, like, what do we do?
Yeah. I mean, the light's here, you know, you can't unpollute at this point.
Yeah, exactly. Do we? And so I'm like, okay, well, we got to figure out some like workaround, right?
Right.
And because there's actually some studies that are coming about LEDs and like how bad they can be for your mitochondria, right? That are
now that's interesting.
Yeah. And so your mitochondria actually becomes sluggish after being exposed to LED lights.
Interesting.
And LEDs are everywhere now. Christmas lights that people are putting up are LEDs. I don't think these are LEDs, but we're around LEDs all day, every day. And so, I think we need to think about the light that and the waves that are being propagated into us and at us. Yeah. And we don't think about that shit. And I think, like, we need to. And it's like, well, then what needs to happen for us to like try to do something different, right? Do people need to start dying because their mitochondria are like becoming severely deterred from doing their job, which is like creating the energy for us to survive? So yeah, that's why I'm excited you're the president, so that I can holler at you about some of these things,
some of these regulations.
I'll have a Google form. I'll be taking suggestions all 4 years.
Yes, that would be awesome. That'd be a lot of suggestions.
Yeah. I was recently watching was it a documentary? And I think it was the movie Lincoln, and to me, he was like one of the greatest presidents of all time. Of course, right? Of course, yeah. And he would take time out of his day. So apparently, people, I'm guessing they still do. I'm not really sure, but you could just go to the White House and sit in a line and try to speak to the president about whatever you think is, interesting or necessary, right? And he would sit down and listen to a lot of those people throughout the week. And, I mean... Yeah, so I like your suggestion box. Because I don't know if any of the recent presidents seem to be taking our suggestions.
Yeah, a bit of a disconnect between the executive office and the actual people,
Yeah.
Which is weird because democracy means a leader of the people.
Yeah, exactly.
We're leaning a little bit too hard towards republic and a little bit too far away from democracy.
Mm-hmm. Yeah.
Did nobody watch Star Wars? Did we not see what happens with the Republic?
Right.
That's funny. Yeah, I just looked into it. So apparently very short blue wavelengths can cause excessive reactive oxygen species production, also known as oxidative stress, in a lot of the cells. And that can damage a lot of the mitochondria. While red light or long wavelength or near infrared red light can be absorbed by mitochondria and improve function of the mitochondria.
Like the opposite of Superman.
Oh, yeah.
Wait, why do you say that?
Well, because the red sun makes him weak,
Yeah.
Superman, yellow sun makes him strong. Because red sun makes him weak.
Because more energy.
Oh, okay. I thought it was the kryptonite that messed with him. That's also a sun as well?
Yeah.
The sun is his boost. That's why whenever he is exposed to kryptonite, he goes to the sun to heal.
Okay. That makes sense.
Man's a plant.
Yeah. Yeah. Well, we all kind of are.
Yeah.
Interesting. Yeah, and so, there's biologists that are looking into... So... Apparently, for the longest time, we looked at, I guess, death as this inevitable thing, right? And now people are starting to look at it as a disease. And if you look at it as a disease, death sort of looks a little bit differently. And what a lot of people are starting to say is that we need to take care of our mitochondria. And the efficiency and the health of our mitochondria depends on how long we live.
Well, it's more like how long we live depends on the mitochondria.
Yes, yeah. And so apparently there's a lot of different things that can be detrimental to your mitochondria, including LEDs and
Oxidative stress.
Yeah, all kinds of things. Partying, probably a little too hard.
Right.
Some substances.
Alcohol, probably. Yeah. And so yeah, there's this podcast that I recently listened to, and this guy was talking about how, you know, apparently you can go in and you can have your mitochondria tested to see like how active they are in producing energy, and so it seems like that you can live longer if you do things to sort of help foster your mitochondria. And I didn't know this, but apparently the sun, like whenever you wake up, it's very detrimental that you go out and you look at the sun and you get the sun on your body, because that actually like wakes up your mitochondria and tells your mitochondria to start producing energy, so that you can
The cortisol cycle,
so that you can then have energy for your day.
Right.
So if you aren't going out and getting that sun in the morning, like, you know, a lot of people
won't want to wake up.
Exactly. A lot of people talk about how like they're sluggish in the morning and things like that. Well, I don't know. Maybe it's because you don't go outside.
Yeah, touch some grass, you know.
Yeah, touch some grass. Yeah. But yeah. Anyways,
But yeah, it's just crazy, right? Even light, even gravity, you can learn about wave mechanics, and they probably follow the same intuition as like how the waves would interact in music.
Yeah.
And wait, that's actually a very interesting thing that I found. It's called biomusicology.
biomusicology.
Yes,
That's a big word.
Yeah. And basically, it's just a study of how music, study of music in the point of view of biology.
Ooh.
And a sub-branch is evolutionary musicology, and they found that there are many debates, obviously. Some say that, like Steven Pinker says, that music is just an auditory cheesecake. Basically, say how we would want fat and sugar, right? And that's why sweet things taste good to us.
Yeah.
But cheesecake did not come from... like cheesecake wasn't part of the evolutionary process, but cheesecake has.
I beg to differ.
but basically, cheesecake has fat and sugar. That's why we love it. It tastes very good to a lot of people.
Okay.
And basically, it says that same thing to music is that we communicate. We have tone. We have, you know, whenever we walk, we have bipedal motion, and whenever we walk, we have rhythm.
Yeah.
We have that's why sometimes we can hear someone's walking towards us, and we know who that is. We can recognize their footsteps.
Yep.
So that rhythm.
Have you guys done that before? I've never done that.
Of course.
Yeah.
Well, I mean, my brother has a click in his ankle, so you know, he just clicks along. I can recognize that.
Or sometimes some people walk by shuffling their foot on the ground instead of actually walking. And you can hear that, and you're like, okay, that's my mother, that's my father, that's my sister.
I mean, I guess you can definitely hear my flip-flops coming in.
Yeah. Oh yeah, for sure. So and we can hear how certain animals walk, like certain hooves, or like maybe bears and their paws and whatnot.
Yeah.
We can hear that, and we'll be able to recognize. And a byproduct of that is our ability to recognize rhythm and beat. You know, and that sense of rhythm and beat, now combined with our tone recognition as a social tool, right? You know how when you're excited or when you're talking to children, you're more high-pitched.
Yeah.
When you're sad and you're down or you're serious, your tone is more deep, right? And that has different social effects. That's why some speakers with a more charismatic voice, right? I don't have a manly voice, so but some people have that. And like for example, you guys have more deeper voice than me. You guys will have more greater effect on some people, you know. So this is a social effect. So combining the rhythm and combining our ability to recognize tone, you create the precursor for music. At least that's
interesting.
some of the theories in
that makes sense.
musicology.
Yeah, that makes total sense, right? Trying to be aware of your predators around you.
And then our communication, because back in the day we live in small tribes. Communication is so important. Social cues is so important. So if someone's happy, you must tell they're happy. If someone's serious, you don't want to bother them. You know? So I think it just makes sense.
Interesting. Yeah, and I don't know, like, you know, yeah, it's kind of hard because I can't go back to a time where I didn't know what music was, and but I think about, like, I wonder if it's like innate in us to just, like, you know, make music with our hands, and I wonder.
And also another thing is our brain likes predictable noise. That's why dissonance is less predictable. But resonance is like what he said. Consonance, resonance is like if they're integer multiples of each other, or their ratio is very close. It's more predictable tones.
Yeah, it's sort of attracted to stability. You know, it's a much more stable tone. Yeah, like you don't hear the beating. Like the beating, that's really like what defines dissonance, right?
That's why screeching sounds so terrible, or tearing sounds so terrible. It's a very unpredictable tone. Well, sometimes tearing sounds satisfying though, but.
The first instrument, a little flute, huh?
Oh,
I was thinking it would have been a drums.
Right? No, that's what I thought.
Oh, bones. Right. Using bones. Wow.
Is it bones? It looks like bones.
Neanderthal flute.
No, that looks like plants.
This guy looks like he's ready to flute it up. Huh?
Oh god.
Yeah, look at that. I don't know why. I just can't picture a Neanderthal playing a flute.
I would think it would be something like a beat, right? Like a drum or percussion.
Yeah, I mean, the first drum might have not been considered an instrument though. It could have been like communication.
Oh, that. Well, to be fair, we used to whistle too, right?
Oh yeah, oldest instrument is the human mouth.
Yeah, because we would sing, we would try to imitate animals to communicate. So I don't know. So that's why a lot of people say, that's another word. Music. Wait. Let me look for that. Musical linguistics or whatever. It's like basically it's trying to say that like music is came from language, because it's an early form of like us trying to communicate.
Some of them, those modern or contemporary instruments may be considered dissidents of antique music.
Functional linguistics. Where is it? There's a word for that.
Several of the oldest. Okay, so it definitely could have been a drum. I would think that it's probably not something that's set in stone.
I feel like
what
singing,
the first instrument is.
I feel like singing would be the first. What he said makes sense.
Yeah.
Like, you know, we can clap. You know, we can like.
Yeah, what's interesting is also like depending on the geometry
of your vocal cords.
And the size of your throat and things like that, and the size of your mouth. Depend on the sound that gets projected out, right?
Yeah.
And because. What is it? It's like the vibration of the vocal cords which creates the sound, right?
Yep.
And that's what was interesting to me. It's like, so the I guess the guitar, right? Like apparently strings don't really make a whole lot of noise themselves, and so that's why you have to have the
tension.
Well, that, and then
you're talking about the guitar, the cavity.
Yeah, the cavity as well.
Resonator. It acts as a resonator.
Yeah, which is fascinating.
Because what happens when something resonates? So when something is in resonant frequency, there's the maximum amount of energy. At least it's in a picture of energy transfer. So if you have two tuning forks and they are in resonant frequency with each other, that tuning fork's vibration will start vibrating the other tuning fork. So if you have a cavity, which is the guitar's cavity itself, and you start playing a string, right? You pluck a string, it starts resonating. The sound goes into the resonation cavity, right? And it starts making it louder each time. It's like swinging, right? When you push a person, as he's going down, he swings faster and faster, even though you're using the same amount of energy, because you're maximizing energy transfer. So,
and then you can change the thickness of the strings, right? That's going to create a different sound.
The tightness of the string.
Yeah, the geometry of the body of the. Yeah, I mean, it would be interesting to just have like $1 million and just go out and play with like making instruments.
In fact, making instruments is so profitable.
Well, it was funny because while researching, I came across a thing that said like, do you know what the name of people who create instruments are?
I have no idea.
Luthiers.
Yeah, luthier.
Yeah.
Luthiers?
And so
I actually never heard of
it
that.
said that these people, the instrument designers, are actually applied physicists, even though they don't really go by that, right? They go by luthiers or instrument designers, right? But yeah, if you think about it, yeah, they're applied physicists, right?
That's cool.
Let's see here. So wind instruments kind of are the physics of them is interesting as well, right? So you can like let's see here. So vibrating columns of air inside pipes, and so. Like the clarinet, it uses like a reed, which apparently that helps in creating the.
So luthier is specifically for string instruments, though.
So I guess it can change the amount of pressure that's being pushed through the instrument, right? And so that's what they talked about a lot too. Is in these instruments that you blow into, right? Is a lot of the sound that comes out depends on sort of how much. How much area you have that you're pushing the air through. Yep. Right?
The biggest complaint that wind instruments get from band directors is putting more air through the horn, you know?
Really?
Yeah. I hear that a ton. I don't even play any wind instruments. They just say it all the time.
Interesting. That makes sense. Yeah. Yeah, I mean, because if you think about it, the more you push it, the more pronounced you hear that sound, right?
But it's like you also need to control the vibration. Like with the reed, that's where the vibration comes from, because you blow on it and buzz on it at certain different frequencies. It'll the reed will vibrate, and then you use the buttons, and it'll give you different tones. But then whenever you think about like a horn, the only thing that's vibrating is your lips. Like you just buzz your lips. Yeah. So you have to balance the buzz and the volume of air that you're blowing through.
Yeah. Talk about trumpet players, how like they can change the tone depending on the position of their lips or like
No, you need to use the buttons.
I mean, it makes sense. And so let's see here. The length of the tube primarily determines the fundamental pitch. So the longer tube, lower tone, which is why a tuba, which is a long tube, sounds low in piccolo. So it sounds low, and a piccolo, which is short, sounds high. Yeah, it makes sense.
Yeah.
Let's see here.
Because the allowed frequency in a long tube is more. Oh, that's interesting. Okay.
And then a cylindrical closed open instrument like the clarinet favor odd harmonics, giving a hollow, reedy timbre, whereas conical bore instruments like bassoons and saxophones and open flute have a full harmonic series. Interesting. So sounding richer.
That's
so something
cool.
that has two open ends has a richer sound, I guess. Interesting.
Wow.
And then apparently like percussion instruments, they don't really have like a it's not really like a tone, it's more of like a
beat.
I mean, you do tune drums, but it's not the same as tuning like a regular instrument. Like there's technically a tone to like a snare drum, like it's like some A or something, I don't know. But like you don't really change it. It just sort of like is to give it the correct feeling.
Thump.
Yeah, the correct thump.
The correct.
Yeah, I'm guessing the smaller the bezel is, right? The sharper the sound.
Instead of a it's probably like a
Yeah,
it's like the high tom versus the low tom. You know, like if you ever seen a drum kit, like there's a little circular drum up here that
It's
higher
like
pitch, right? But then they got the big circular drum right here.
Yeah.
You hit that one is big thud.
Yeah.
The thud is more deep.
So like
because you have
they're tuned to different notes, but really what you're hearing is just the thud. Like because it's not like it's a drawn out thing. You're just hearing in that instant. It just has to resonate a certain way. Right?
Yeah, that's like a pulse. Yeah. Interesting. Interesting. Yeah, and then it gets into like the physics of the ear, right, and like how we're able to hear things, and
The vestibular system.
Yeah. Dr. Ben Jobber gave a talk for Physics Society and went into this, right? And apparently, like you were there?
Yeah, I was at that one.
Oh yeah. Okay, yeah. So, apparently we have these like very specific hairs in our ears, which I guess like sort of grab those sounds, or like or it's sort of like uses to vibrate.
Yeah, the vibration. I can't remember.
So have you heard of the eardrum?
Yeah.
All right. So basically, when there is a piece of tissue at the end of your ear, right? There's also another hollow space in there. When sound comes in, it vibrates that tissue, and that signals nerves. The hairs is the vestibular system. The auditory system uses that drum.
Interesting.
The hairs in the vestibular system comes in 3 loops, and whenever you move, the fluids flow. Right? And that causes the hair to move. And when those hairs to move, they send a signal to the brain telling you, oh, you changed orientation. Now that's the vestibular system. The auditory system follows the eardrum.
I see.
Interesting.
But they are connected. That's why some sounds can make you feel disoriented.
Wow.
Infrasound.
Full circle right now.
There was another thing about Bach that was very interesting. So apparently, like information theorists were analyzing his music, and they said that where is this at? Where is this at?
Devils. Interval.
Physics.
That's pretty interesting. The Devil's Interval. The most unsettling tone in music. C and F sharp.
Where the heck is that?
Is one of the 6.
Oh, here it is. Okay, so modern researchers have even applied information theory to Bach's compositions, treating them as networks or interconnected notes. A 2024 study found Bach's pieces efficiently balanced predictability and surprise to convey musical information to the listeners. In short, Bach's work epitomized the synergy between music and math. He wasn't the first to think about music mathematically, but Bach demonstrated how mathematical organization and beauty can intertwine in music at the highest level. So yeah, essentially like the predictability and surprise, right? So apparently not only do certain sounds sound interesting to you, right? But if you were to just hear that nice sound over and over and over and over again, you're not gonna like that either. So you need some sense of surprise, right? Some sense of sort of like unpredictability, that sort of element to the music as well, for it to sound even more pleasing, right? Right, because if you listen to Bach, right, it's almost as if, right, as soon as you sort of get lulled to sleep, there's like it changes, and yeah, there's something interesting about that as well, like how just like as humans we hate repetition. Right, you know. I mean, I'm not gonna lie. I have a lot of like repetitive things that I do, you know, throughout my day, and I make sure to do them every day. But at the same time, like, I also try to switch it up, right, a little bit. Right. That's why I like learning new things like throughout the day. It's sort of it cuts through that repetitiveness, right? Yeah, I don't know. It's so weird.
It's like consistency is a good thing, but too much of any good thing becomes a bad thing, right?
Yeah.
Like you could eat too much broccoli and accidentally kill yourself, but broccoli, you know, in a consistent, moderate basis, like, of course, you're gonna improve your health.
Yeah.
So it's like, for music, you know, it could always be like, it could just be the same beat over and over again. Like, man, that's a pretty cool groove. And then it just plays that for 5 minutes. Like, of course you're going to get tired of it, but that doesn't change the fact that it's a good groove. It's just getting bad, you know?
Yeah. Yeah. So do you play anywhere, or do you like, I don't know, are you part of a band or anything like that, or?
You know, I've bounced around with like different groups and stuff, but right now I'm sort of sticking with like the school regimented. Like I was at a jazz combo for the School of Music. You know, I auditioned for it. We had a couple concerts. It wasn't anything crazy, but you know, I've always been, you know, stuck with the school affiliated music. I've been wanting to branch out more now that I'm not like I don't go and take a class every single day. Like, it's like I have to do it on my own time now. So I'm really, you know, I'm looking for the opportunities. Anybody watching the podcast,
heck yeah,
feel free to hit me up.
Yeah. Well, I would put it out on the Discord, because apparently we have a couple musicians on the Discord as well.
You know, man, feel free. I always love like meeting up with other musicians.
Yeah. So do you go to listen to a lot of live music, or?
When I can, I do, but like, it's just not like I don't want to say that I feel like I'm busy, but you know, like I can always find something else to do rather than just go sit in a building for a few hours and listen to music. Of course, I love listening to like live jazz and all that. That's really the only music that I've listened to live. Like, I've never been to like a real concert, you know. Okay. But you know, I love listening to live music. It's always
never been to a concert, man.
I mean, I've been to concerts. I went to the OKC Philharmonic one time. That was pretty cool.
Yeah, let's go.
But I've never been to like Kendrick concert, you know.
Yeah.
Like you know, never like halftime show kind of thing. Like, I've never seen one of those.
I see. Yeah. So every what is it? So the last Friday of school, me and my girlfriend, we always go to the Nutcracker.
Fun.
So every year they have the Nutcracker here at the I forget what they call it, the Oklahoma Philharmonic or something like that, or it's I don't know if you guys have ever been to the Nutcracker, but it's pretty lit. I'm just gonna say that.
Man, that Sugar Plum Fairy, man.
Yeah. But yeah, no, it's interesting because I feel like I'm gonna like look at it a different lens after this, because I don't know. I think I'm gonna start like trying to look for like the certain things in the music that like we've been talking about.
The strategic dissonance.
Yeah.
You know?
I mean, so whenever you listen to music, is it kind of? I mean, how do you enjoy it with like it also being sort of something you know technically?
So I definitely like, since I've been starting to learn the more technical side of music, I do try to focus in. Like, if I hear like a crazy minor chord just thrown in there, I'll be like, man, that's very out there. That's very innovative. But like, you know, I'll listen to the beat. I'll always like time signature is something that I'm a big fan of. Like, most songs are in just like 4/4, just 1 2 3 4 1, like over and over again. But like there's a lot of really great songs that are in like 5/4 or 3/4. Like, you know the rhythm of a waltz?
Okay.
Like 1 2 3 1 2 3. Like, that's 3/4, and that, like, I love a good waltz.
Okay.
Like, my top song this year, I don't have Spotify, sadly. I use Apple Music, but my top song this year was the Great Pumpkin Waltz.
Okay, let's look it up. The Great Pumpkin Waltz.
You gotta pull it up.
And if you can find it, the Chick Corea version, that's the main one.
The Chick Corea version?
Yeah.
What the chick? Yeah, I've seen a lot of Charlie. Here, I'll put it up here.
Man, Charlie Brown is
Charlie
the
Brown.
shit, man. Charlie Brown is the shit.
So should I play this one then?
Yeah, go for it.
Okay.
Yeah, that's the classic.
We got strike by this.
Okay, all right.
Battery, high.
We're just having fun. Okay.
1 2 3 1 2 3 1 2.
Yeah, I hear it now. Yeah, it's just so pleasing to the ears, right?
And it's sort of, you know, it feels a bit different than the average song that you would hear because it's in a different time signature.
Let's see if I can find the Chicory version you said. Here, let me. I'm sorry to cut you off. What were you saying?
I mean, it's just like, time signature goes into like a lot of the feel of music. Like something in 7/4, like you might not notice it at first because it might just feel like, regular like 4/4 and then just a little bit off, just to the like average listener who doesn't like know about time signature. They might just, sounds like every other song, but once you really know about it, you can enjoy it a bit more because you're like, this is technically impressive. Like this is actually
technically impressive.
Yeah, like this is significantly more difficult than just playing in, classic 4/4 time signature. So it's just something that I've
Can
started
you
to
expand
notice.
a little bit more on why it's impressive? Like,
So pretty much I don't want to say everybody because of course there's gonna be some exceptions, but like everybody starts playing in 4/4. So that's four notes every measure, just going straight through. Every note is just a quarter note, so it's a quarter of the measure.
okay.
But then you get into like 7/4, and then there's like 7 notes in every measure, so it has a like if you notice it, it's a very different feel. Or like even just 5/4, like it's 5/4 might be a bit harder to pick up on than 7/4 because less difference. But
Can we look up? Let's see here.
let's get some 5/4. Look up Take 5. It's a great jazz tune.
Take 5.
Yeah, Dave Brubeck.
Sure. Okay.
1, 2, 3, 4, 5, 1, 2, 3. Yeah.
Yeah, I've heard this song before.
Yeah.
It's the highest selling jazz single of all time.
Really?
Yes.
1, 2, 3, 1, 2, 3, 4, 5. That's cool.
Yeah.
I like that.
Okay, now let's look up what's another one? To switch up the tone. You said that was a 5/4.
Yeah, that's 5/4. I can't remember it at the top of my head, but if you look up just 7/4, there's a song that's literally just called 7/4. If you just put 7/4.
Oh, okay.
No, it's slash, right?
Not dash slash. Okay.
Then I'm sure. Yeah, let's take a look at that. I can't remember any off the top of my head.
Across the majority of popular music, only a small set of influences seem to, and then a group of 3.
Climbing up on Salisbury Hill, I could see the city lights. Wind was blowing, time stood still.
So that's 7/4.
Yeah,
In
that's
fact,
7/4.
to make this grouping clearer, songs in 7/4 are sometimes transcribed as bars of alternating 3/4 and 4/4 like this. This of course doesn't change how the music sounds, but it might make it easier for the musician to conceptualize the rhythm. Of course, an obvious drawback of writing it like this is that the page is suddenly a lot messier and the musician now has to keep track of when the signature is changing. Despite this grouped feel.
Okay, now I want to go back here. Yeah.
Wow.
Sorry.
It still works, of course, but it's
Oh, it's funny. I was just watching this video the other day. this morning.
Veritasium is the best, man.
Yeah.
So okay, why does the 5/4 sound more? Well, I guess it sounds more upbeat because it's. Yeah, why does it sound more upbeat almost?
I think that comes down to tempo, like specifically in this case, because this is a much sharper key,
Okay.
much more. Not sure if it's major or minor just by looking at it, but the Dave Brubeck song is definitely it's in a minor key, but it's really high pace, heavy swing. This is like almost down to the battle like.
So you can have a ratio, but then change the tempo.
Yes.
Okay.
So the tempo is entirely independent of the ratio.
Okay, that makes sense.
So like if you have like a 5/4 song, but it's going at like 100 beats per minute, then it'll be like 20. Excuse me, like 20 measures a minute. So it does translate, but like if you were going 125 beats per minute, then it'd be 25 measures in 5/4.
What's another ratio?
6/8 is a pretty good one.
6/8. No, not 6/7.
Not 6/7.
Get the hell out of here.
No way.
Let's see here.
Oh, songs that use 6/8.
We're just.
Yeah, no, we can just watch that one. So, difference between 3/4 and 6/8.
Sorry. I wanted a specific song. Why don't they give you just like a specific song that uses 11/8, 6/8?
Oh yeah, that's a good one.
Hey guys, how you doing today? I have a lesson.
Interesting.
I don't know. I count that as a 3/4. I might be counting it wrong.
So
like, what the
that's the thing, because 3/4 and 6/8 are essentially the same thing. You just count them a little bit differently.
Yeah.
Like so if
It's just a multiple of 2, right? I mean,
yeah, pretty much. So on the top is the number of beats in the measure. So that's like how many before like the rhythm repeats essentially. And then the bottom number is what type of note gets the beat, right? So for 4 it'd be a quarter note. So that's just like one beat just in a row. But then for 6/8 the 8th note gets the beat. So that's like the 2 notes together. And then in 6/8, typically what it ends up being is a triplet, which is just groups of 3 8th notes.
Wait, they have this guy has a video of all the different time signatures.
Oh, okay, that'd be cool.
Time signatures. Do they know things? Find reason in a promo bunker in written music and
This video looks very.
And you play until they cut it off. Now, 2/2, or cut time as it's commonly known, not to be confused with common time, which is 4/4, which is essentially the same thing, is just counted in 2, and it's usually this kind of feel. 1 and a 2 and a 1 and a 2 and a 1 and a 2 and a... in jazz, or polka, punk rock.
Polka.
It's easier to count in 2. 1, 2, 1, 2, than to count 1, 2, 3, 4, 1, 2, 3, 4. And that's why something would be written in cut time. Now, 3/4, also known as a waltz, in its most basic form.
Orion's favorite over here.
Yes, sir.
Threw a little jazz waltz in there for you. Now that brings us to 4/4. And everybody in the world turn this beat. And that's 4/4. Brings us to common time. The type of music that's in everything from pop to rock, and the list goes on and on and on and on. Our first odd time signature, 5/4.
On time.
Usually this is like the most common.
Okay, so odd times here when the numerator is odd.
It's
Yes.
Dave Brubeck's.
What about 1/1?
And the drummer on this track is.
That's odd, isn't it?
Or 3/4.
Not technically.
Not technically?
I mean, no, technically.
Oh,
yeah.
okay.
Technically, yeah.
All right.
So my question is like, so depending on the kind of music you're gonna play is dependent on the ratio you're gonna use?
Well, I mean, you can use any ratio for any genre of music necessarily, but definitely like pop, you're not gonna see many 5/4 pop songs. You know, waltz music is typically associated more with classical, right? So a lot more 3/4 in classical than in pop. Like 4/4, that's why I called it common time. Like most music is in 4/4, just almost for just simplicity's sake. But like you can play, I mean, you could make a pop song in like 5/4. Be pretty cool, be pretty interesting. But like cut time, that's usually like he did the jazz example. Like that's just like whenever you're trying to play like a super fast song, you don't want to count that fast. Or like polka was a good example. So I mean, it's not like neither of them are dependent on each other, but they definitely affect each other.
So then my question is like, so is the 808 drums, is that speaking to a ratio, or what is that? So
808s essentially act as like the bass whenever you don't have a person who can play the bass. So it's just like it'll give you the rhythm, and by counting the 808, like the intervals for the 808, you can usually figure out the time signature easier than if you were like going based off the lyrics or something. But it's not like the 808s they set the time usually. Like the bass usually sets the time, and like shows like where we are in the measure, right? Like for a 4/4 just like regular jazz song, or like even like 4/4 like hip hop song where they're using 808s, it might be like less on 1, emphasis on 2, less on 3, emphasis on 4. So it's just like sort of there to outline almost.
Interesting. So I got a question for you. So why do you think I mean, other than because it sounds good to you, right? Why do you think to you jazz is like your favorite?
You know, it's very technical. Like, of course, there's cool sounds like minor chords and all that stuff. Like, you get the big chords from jazz. Like, you put a whole bunch of notes in a jazz chord. You know, like gospel, three note chord. You know, pop, 3-note chord. Jazz, you put in that 4th note, that 5th note. You know, raise it up, get it all fancy and complex. So it's just like very, I don't know, I don't want to say it's like I like it because it's difficult, but I like the idea that it can become difficult is very interesting. And like as it gets more difficult, to some it sounds better. You know, to some it sounds worse, and they like the more simple stuff. But like as you increase the difficulty and like the complexity of the music, it can really add to it. And whenever you add extreme complexity to jazz, to like pop music, people don't like it. They don't like it too complex. Or like you add it to rock. Like rock is some of the most simple music. Like
shots fired.
Yeah. No hate to rock. My first love was metal. Okay. My first love was metal. But like simplicity and complexity really need to come together for a whole lot of music genres. But for jazz, like if you just go all in on the complexity, then you can still have a good song. Or if you go all in on the simplicity, you can still have a good song. But like for everything else, you need to mix it in a certain way that like it appeals to the common ear, but it's also appeals to the musician ear, right? Like it has like a draw to it. But for jazz, most people who listen to jazz in like that way, like, oh yeah, jazz is my favorite, typically they have some sort of like they sort of know about music in a way that makes them able to appreciate the complexities that people put into it, you know?
I see.
Like Take 5 is not an extremely complex song. It's very like consistent chord progression, like, you know, very just driving drums, like very, you know, good swing, just like catchy, you know? But then there's other songs like Giant Steps, you know? Giant Steps is definitely a lot more technically complex. It's
pull that up.
like probably I don't want to say it's John Coltrane's biggest song, but like it's
okay. It just starts off like getting after it. It almost feels like it doesn't like catch up with itself. It's like
yeah, that's the laying back that I was talking about, you know, the swing. And you know, it's kind of funny that there's a video right there. Giant Steps is actually very simple, but
Giant Steps is easy. Giant Steps.
Okay, yeah, that's a song we just
but it's definitely like your ear isn't accustomed to hearing those tones in that order because it's more of a like it sounded sort of almost random, right? Like da, 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 like sort of all over the place. But whenever you understand the intentionality behind it, it becomes a lot more attractive to listen to.
Yeah.
So like for jazz, it's just like the complexity really makes it for me.
Yeah, some of my favorite songs are songs that start off one way and end in a different way. Like it's almost like two stories in one, almost. I can't think of a good example off the top of my head, but what is that? What is the name of that? Breathe by they're like a 70s rock band, not Pink, not Pink Floyd. Yeah, there we go. Breathe by Pink Floyd. It starts off like one way and then it sort of ends in another. It's but yeah, is that sort of, I mean, yeah, to me like it seems like a complexity would mean that there's just a lot of different elements, right? Or
changes.
Yeah.
In the song.
Yeah, because you're almost like you start somewhere, but you end somewhere else, and you're trying to figure out like what's the best path there.
Oh yeah.
You know.
I mean that's a good way to think about it. Like you can, like of course you could have the simple straight line path where you're just essentially going the same thing the whole time, and then it sort of just like gradually shifts to this thing, or you could, you know, put a few waves in there, get it complex, hit a couple jumps around, and really get it freaky, you know.
Yeah. I mean, my almost favorite way to talk is to, I don't know, start off from an idea that I have and then just figure out where it takes me, right? I don't know. It's almost like, it's sort of like almost like an art to talking is just like, you know, how can you sort of, you know, portray the information you're trying to portray, but then also in such a way that is not predictable and isn't like very repetitious, right? And then at the end you end up somewhere completely different, which is I think why I like diving into so many different topics, is because you can start off in physics and end up in chemistry, or start off in quantum physics and end at music, right? Yeah. But anyway, so is I don't know, is there something that you've been wanting to, I don't know, because you talked about how, you know, whenever you were a kid, you wanted to go into theoretical physics, right? Is there something about theoretical physics that you've been wanting to dive into for a long time, you just haven't?
I mean, like quantum mechanics, you know, it's all very theoretical right now. I always sort of associated that with theoretical physics, and that's always been super interesting. Like the super small stuff, like, because that's everything. Everything is all these little tiny elementary particles. That's everything. And that's crazy to me.
Yeah. And when you find out that there's like a zoo of particles, right? There's just and to think that maybe we haven't even gone as
deeper.
small, like that there's a possibility for even smaller particles is to me like wild. And then you think about the opposite end of the spectrum, which is like
how big things can get.
Right. Are we just, is our real universe just one single universe, or is there like multi-universe, or is it just
one infinite universe?
Yeah.
You ever seen like Horton Hears a Who? We could be like Horton Hears a Who. We're just like one little speck, and like the whole universe is like a whole different world. Like that, we could be on a tiny Earth on top of a tiny Earth on top of a tiny Earth.
Yeah.
It'd be pretty crazy.
Yeah. Oh my gosh.
I mean, I think the most interesting thing that I learned about like the other side of the spectrum is because the cosmological principle states that eventually especially when you zoom far enough, right, the universe should look very like homogeneous. But the problem is that that's not what we see. They found voids, giant voids, and they also seen giant structures. There's a wall of galaxies that spans 11 billion light years, which is like what's 11 over 92?
11 over 92?
That's almost like how much percentage?
It's almost 10%.
Yeah, it's 10% of the observable universe. That is a giant structure of galaxies. We don't know what's that. And the voids, the giant voids, we don't know where they came from. And like the scariest part is the great attractor, right? We're moving, all these giant structures seems to be moving towards a direction, the great attractor, and then something seems to be on the other end, seems to be repelling everything, the great repeller. We don't know what those are either. So,
but that's what's sort of fascinating to me about you is you seem very curious
about a lot of things.
Yeah, but at the same time, you want to go be the president, and nothing against that at all. But I just like,
I think you could be a good advocate for science.
Some people,
I mean, that's definitely. Oh my gosh.
Yeah.
I'm gonna fund so much research, man. It's gonna be crazy.
Please do.
Yeah. Okay. Yeah. I didn't think about that really. But I guess my thing is like, because every now and then I think about, going into politics because of kind of like what you said, right? Like you maybe see some things that seem to be, I don't know, issues in the world. And I think that, sometimes I feel like maybe I could fix those things, right? Maybe we just need the right policy or something like that, right? Is that your?
No.
Is that me? Is that my phone?
Nope.
Uh-oh. It stopped. We're good.
Where did that come
I think it's my phone. Maybe.
really?
Yeah. But yeah.
I had that sound as my alarm for a long time, and that just gave me like PTSD, dude.
Yeah.
So
I was like, whoa, what happened?
Yeah, I don't know what I'm trying to. I don't know. I guess it just comes to it's interesting to always see where people think that they could make the biggest impact. That's what's interesting to me. Because for me, I think, well, maybe the biggest impact that I can have is going and teaching things, and maybe trying to
research.
Yeah, and doing research, and maybe trying to find out, the answer to the question of, why are we here, or something like that.
Right.
But to me, it's interesting because a lot of people talk about how the president doesn't really have the power that we think they have.
That's
the checks and balances, right?
Yeah, that. But then also at the same time, like, there's some conspiracies about how the CIA runs everything.
The deep state.
Yeah. Secret Service runs it all.
Yeah, exactly. So I don't know. Yeah. Also, at the same time, I'm like, heck yeah, like we shouldn't let that keep us from still striving to be in that position, right? Because, but also at the same time, the people who have tried to create the most change have ended up in a casket, right? Yeah.
That's why they don't like the word social reform.
So yeah, I don't know. Yeah, so if anything, I think it's very courageous.
I mean, considering how like you want to be a president, you want to be a professor researcher. For me, I want to be a professor researcher as well, but I plan to like towards the end, like maybe towards the later years of my life, I plan to join like either WHO or United Nations to be a part of the advisory board or something like that to get into policy making as well as like advising politicians about like science stuff. So I feel like we're all trying to do pretty much the same thing, just a different way. That's what I find interesting. We're trying to influence society to go in a better direction with our own various methods. Pretty cool.
Yeah. My thing about the president not being able to do the things that people say he does, like just think about how much influence he has just by being in that position. I keep saying he, how much influence the president has by being in that, just being there, right? Like if I were as president to just like put out a broadcast every day of like, these are the things that I want to see, these are my opinions that I hold, and I make it public. Like, just think about how much that'll influence the people who voted for me, the people who didn't vote for me.
Because it's transparent.
Yeah, like the transparency and like just putting these ideas out there from a position of authority. It's sort of like an appeal to authority. Like in the most literal way, it's an appeal to authority. Like when you are the authority, you get to set the precedent, because it's just like, that's the power of your voice when you get to that position. So even if I can't actually directly enact policy, pass like executive orders, it'll still have an effect. Like what I say will still have an effect simply because that's where I am.
I like that. I say we end it there.
Fair enough.
I think that's perfect.
All right. Well, Orion, thanks for doing this.
Thank you for inviting me.
Yeah, it's been real fun. I've been wanting to dive into some physics of music for a long time.
So I'm not more knowledgeable on it.
None of us are.
Honestly, this podcast is probably one of the podcasts I learned the most from. Honestly.
Cool.
Yeah. And I learned so much about how you can use politics with the engineering side of the view. I was like, dang,
it makes sense. And honestly, people have been talking about needing more engineers or technology-minded people in
politics. We need more, and I think you're a very good representation of that. I think that's very cool.
Well, go vote for Orion.
2044, first year I'm qualified. 2044,
sir, that would be awesome.
Let's go. Well, all right, like I said, we end every podcast with until next time and then a clap. So until
next time.
All right.
Hey, it's the perfect time. We didn't even count. That's awesome. Okay.